What's going on, everyone, and welcome to the Aimtec Academy, the best place to learn about Aimtec products as well as to enhance your overall knowledge on the power supply industry. Today's course is going to be on Aimtec and the medical industry. So how can Aimtec products be used in the medical industry? And we'll also talk about the medical certification for this industry. Without further ado, let's hop into the course. Hi, and welcome to Aimtec's course on medical power supplies. Modern medicine uses a wide range of equipment to detect and treat diseases. These equipment are critical to the healthcare professional and often can be the deciding factor in saving lives. These tools and equipment are used by doctors who benefit from the most rigorous testing and stringent standards. The power supplies that power these devices are also subject to strict standards to ensure that safety of both the operator and the patients are met. Now, this medical standard is IEC 6061-1 and is composed of multiple components, but will be only focusing on the following three. The first one is means of protection, or MOP, and this MOP component protects patients and operators from the risk of electrical shocks. There are two types of MOP, means of operator protection, MOOP, and means of patient protection, MOPP. As patients may not be able to react to electrical shocks, stricter protection requirements are applied for means of patient protection. Means of protection can be achieved by creepage, clearance, and protective earth connections, also known as your ground. Based on the working voltage of the medical equipment and devices, different distances of creepage, clearance, or tests are defined. For certain medical devices, 2 times MOPP or 2 times MOOP may be required. Next, we'll be moving on to applied parts. Depending on the type of medical device, physical connections between the patients and the medical devices may be required. Such connections can carry leakage current and can cause potential danger to the patients. To determine the required level of protection, the applied parts, which are parts that will have contact with the patient under normal use, are categorized into 3 different types. And the 3 different types are cardiac float, and body. So the cardiac float is connected directly to the patient's heart. For example, an artificial pacemaker or an automated external defibrillator. Next, we have the body float, and this is when there is a direct connection to the patient. For example, we have a ventilator or an ECG monitor. Finally, we have the body type, or type B, which is not in direct contact with the patient. And for example, we have intensive care beds or medical x-rays. And even though, yes, the patient is in contact with the machine itself or with the bed, there is no electrical connection between the two. Finally, the last component is low leakage current. For those who don't know what leakage current is, it's simply the current that managed to escape the circuit and may actually get to the patient. And depending on the amount of current that gets to the patient, this can cause severe damage. So, for example, if a patient is in contact with 0.5 to 5 milliamps of current flowing through the body, it can cause involuntary muscle spasms. If exposed to between 5 and 40 milliamps, strong involuntary muscle spasms, immobilization, and heart arrhythmias may occur. If more than 40 milliamps flow through them for over 3 seconds, cardiac arrest, breath arrest, and other severe cell injuries may occur. Preventing such current is especially important when it comes to patients, as they might not be conscious or have the ability to let go, as we mentioned earlier. So if we're looking at the table below, we see that for the least stringent type body, or type B, we have 100 microamps under normal condition and 500 microamps under single fault condition. And if we look at the most stringent one, which is type CF, we have 10 under the normal condition and 50 under the single fault condition. Now we'll be moving on to how Aimtec power supplies can be used in various medical applications. First off, we have the automatic nucleic acid extraction instrument. This is the starting point of most biomedical experiments. As a nucleic acid extraction device is not placed in the patient environment, the information and communication technology equipment, or ICT grade, of electrical systems is sufficient. However, high EMC performance and strong interference immunity are needed to prevent interference to the data acquisition device. In the block diagram, we can see a communication module, industrial PC, HMI, and so on and so forth. all of these modules are powered by different Aimtec power converters. So the main power source comes from an AC-DC power supply, or the AMESP-NZ, which is a brand new enclosed high-power AC-DC converter family. And as you can see in the block diagram, we suggest anything between 75 watts to 350 watts. These converters also come with a PFC function to increase grid interference immunity. Next, we have 3 isolated DC-DC converters that provide the required voltage level to each component and isolate the interference. Now we'll have a look at the medical X-ray machine. These are crucial components in clinical diagnosis. There are 3 types of medical X-ray machines: the computed tomography, the fluoroscopy, and the conventional X-ray. As the X-ray machine is within the patient environment but not electrically connected to the patients, the machine is required to meet Type B applied part standards. The block diagram is an example of the control system of a C-arm X-ray as seen in this picture. The machine consists of an MCU, X-ray module, displacement detection module, and image intensifier. This example uses ITE grade AMESP-NZ AC-DC converters just as the previous example, which provides 24 volts to the system. 3 medical grade converters with 2 times MOPP convert the voltage to power the other modules. Customers can choose between the AM60W-NZ with 6,000 VDC of isolation or the AM20EWM-NZ with 5,000 VAC of isolation to satisfy the required creepage and isolation protection requirements. Now this will all depend on the different power levels that you need, because the AM60W is 6 watts and the AM20 is 20 watts. Now we can have a look at the Immunoassay Analyzer. This machine is used to identify different substances of interest in a given sample. The basic concept is to use labeled molecules that are coated with an antibody to target substances of interest and highlight them. The labeled molecules will emit light under certain wavelengths, which will then be captured by the photosensor. This captured data is then analyzed to produce the test results. Similar to some of the previous examples, this is not placed in the patient environment, therefore will only be subject to the ITC grade. The analyzer consists of an inspection unit, a cuvette loading system, a sample loading system, and a control communication module. Again, we have Aimtec's AMESP-NZ series providing 24 volts of required power to the high voltage generating heating device and valve directly. 3 isolated DC-DC converters convert the 24 volts to 5 volts and 12 volts to power the sensitive communication module and high EMI motors. Other modules are powered by 3 cost-effective non-isolated switching regulators. And the reason why these switching regulators are more cost-effective is because they don't have any isolation, and you can reach much higher powers for a much lower cost. Now we'll be having a look at ventilators. Ventilators are designed to aid the patients who cannot breathe effectively or are unable to breathe by themselves. This life-saving equipment consists of a pump or blower that can transfer breathable air in and remove carbon dioxide out of the lungs. Depending on the way it delivers the breathable air into patients' lungs, a ventilator can be divided into 2 types, an invasive and a non-invasive. The non-invasive ventilator delivers air into the patient's lungs through a face mask that covers the patient's nose and mouth. An invasive type delivers air to the patient's lungs by an endotracheal tube that goes through the patient's nose or mouth into their windpipe. Modern ventilators are usually computerized equipment consisting of a blower, several sensors, and valves, as we'll see in the upcoming examples. The blower pushes air from the gas source, which can just be a mix of oxygen or a mix of oxygen and other elements, through the inspiratory valve and multiple sensors and eventually into the patient's lungs. At the same time, the MCU monitors the readings from the sensors and controls the blower speed or valve opening to achieve the desired pressure, flow rate, and oxygen levels. So we'll start off with the intensive care ventilator. This is the most large ventilator and features a wide range of flow rates and pressure settings and is often bulkier than other types. These ventilators, as we know, require a physical connection with the patients, hence need to meet the BF applied part standard. As the device is usually capable of higher flow rate and pressure, a more powerful medical grade AC-DC converter from 200 to 300 watts is required to be the main power source. In this example, the 24 volts provided by the Aimtec AC-DC converters power the display unit and the pump motor directly. 4 isolated DC-DC converters convert the 24 into 12, 5, and negative 12 volts. As the valves usually generate more electromagnetic noise, customers can use our AM10 TWM-YZ or AM20 EWM-NZ, all depending on the power that's required, dedicated to these valves to isolate the interference. The 5 volt levels, which is also provided by our AM10 TWM-YZ or AM20 series, powers the electrical control circuits and the communication module. To ensure the RS-232 signal quality, customers can use our AM1DM or AM2DM, which are 1 and 2 watt DC-DC converters respectively, to provide 6000 VDC isolation to power the signal line. The negative 12 volts provided by the AM2DM offers the necessary reference voltage to the OPA and DAC. Next, we have the transport ventilator. Since it's meant to be transported, this is much smaller than the previous ventilator. Since it's smaller, it only requires about 80 to 150 watts of power. In the block diagram, we see that the device is powered by an onboard medical-grade AC-DC converter or an external 24-volt medical-grade adapter. The 24 volts from the onboard AC-DC or external adapter powers the motor and the valve directly. To isolate the interference from the motor and valves, Aimtec's AM20 EWM-NZ DC-DC converter with 5000 VAC isolation is used to convert the 24 volts to 5 volts and provide power to the control circuits, sensors, and display unit. The AM1DM or 2DM-NZ are also used in this example to ensure the signal integrity to the RS-232 communication module. Now, for mechanical ventilators, which are actually the smallest size and therefore require even lower power. And again, Aimtec's medical-grade DC-DC converters, the AM20 EWM with a 4-to-1 input voltage range, is built into the device to enable a flexible external DC power source. The input power is converted to 24 volts and powers the valve, blower, and system fan. Switching regulators, which are again non-isolated DC-DC converters, can be used to convert the 24 volts to 9 volts and 5 volts to power the sensors and the microcontroller units. Next, we have the Uvc Cabinet Drawer. Most surface disinfection methods consist of using chemicals. The efficacy of these methods depends on the selected agent, manner of use, and the treatment time. Electronic devices such as phones and tablets can't be exposed to these strong chemicals as they can cause corrosion or damage the actual devices. That's why we use UVC rays to disinfect such devices. And in this case, we'll be looking at the Uvc Cabinet Drawer, which is a small enclosure where you would put the device in it and it would disinfect it for you. And since it's not placed in the patient environment, the information and communication technology equipment, ICT grade electrical power supplies, can be used to power these devices. In the block diagram, a UVC LED array is used to achieve surface disinfection. Aimtec offers 30 to 60 watt AC-DC LED drivers to convert the AC source to DC output that is able to drive the UVC LED array directly. The MCU, LCD display, touchscreen, and sensors also need a DC power source, which can be achieved via Aimtec's compact AC-DC power solutions like the AME3CJZ, the AME3-HAVZ, and the AME3-VZ series. Following the same category, we have a UVC disinfection robot. This is the same idea, except that there are UVCs mounted on a robot or on an autonomous driving unit that goes around in hallways or in rooms and is able to disinfect them. The power source for this device is a 48 VDC battery, which drives the motors, laser sensors, camera, computing device, and the UVC lamps. Aimtec's AMSROL-10-NZ can convert the 48 volts to 24 volts, which mainly supplies the power to the brain of the robot, the computing platform. The AMSRI-NZ converts the 24 volts to a 12 volt, which powers the camera and sensors to give the robot the ability to recognize and see objects or obstacles. Again, these two series are actually switching regulators, which again are non-isolated DC-DC converters. Isolated DC-DC converters, such as the AM6C-NZ and the AM6G-Z, offer isolated 5 volts that can supply the power to the sub-control system and peripheral sensor. The AML-DV-NZ, which is a DC-DC LED driver, can convert the 48 volts to 5 volts from the battery to power the UVC LED array that disinfects the environment. And just as a quick note, here is a list of the Aimtec Medical Series. We go from 1 to 20 watts in the DC-DC category, and from 5 to 40 watts in the AC-DC category. And again, it's important to look at the means of protection column to determine whether or not it's MOPP or MOOP. And in the safety column, we can see that the standard, as we mentioned earlier, is 6061-1. Well, guys, thanks for tuning in. Hope you learned something today. If you want to have a look at all of our medical products, you can easily go on aimtec.com and click on either our catalog or application guide to see all of the medical AC-DC or DC-DC converters that we offer. Also, if you have any questions or comments about the course, feel free to reach out to your local Aimtec representative and we'll be more than happy to help you out. Thanks for tuning in, and we will see you in the next course.